वेलकम टू स्टूडेंट पांडा क्लासेस। मैं महीधर साहू और आज हम पढ़ने वाले हैं कूलम्ब्स लॉ। राइट, कूलम्ब्स लॉ एक टॉपिक है इलेक्ट्रिक चार्जेस एंड फील्ड्स चैप्टर का। कौन सा चैप्टर? इलेक्ट्रिक चार्जेस एंड फील्ड्स। आप यहाँ पे देख सकते हैं इलेक्ट्रिक चार्जेस एंड फील्ड्स चैप्टर का एक टॉपिक है कूलम्ब्स लॉ, जो आज हम करने वाले हैं। राइट, एंड व्हेन आई से कूलम्ब्स लॉ, जब मैं कूलम्ब्स लॉ की बात करता हूं तो बेसिकली ये होता क्या, व्हाट इज दिस? राइट, it talks about force between two charges. When I say Coulomb's law talks about force between two charges. See, basically try to understand this, right? There are four forces which has made everything in this universe, and one such force is electromagnetic force, and this one over here is also electric force which comes under electromagnetic force. So we'll be studying about one such force, right, in which we will be learning about that force from Coulomb's law. Right? So basically Coulomb's law, what do we understand from Coulomb's law? There are two charges, one is Q1 and Q2. So between those two charges, how much the force will be there, that is what we will be learning from the topic Coulomb's law. Right? What basically Coulomb's law tells us? It tells us the force of attraction, the force of attraction or the force of repulsion between two electric point charges. राइट, बिटवीन टू इलेक्ट्रिक पॉइंट चार्जेस। इसका मतलब है अगर दो चार्ज है यहाँ पे, एक है Q1 Q2, ये Q1 Q2 कैसे होने चाहिए? ये इलेक्ट्रिक पॉइंट चार्जेस होने चाहिए। राइट, एंड दीज इलेक्ट्रिक पॉइंट चार्जेस, व्हेन आई से अबाउट दिस इलेक्ट्रिक पॉइंट चार्जेस, बिटवीन दीज टू चार्जेस देयर विल बी अ फोर्स। राइट, एंड दैट फोर्स विल बी इक्वल टू हाउ मच? दैट फोर्स विल बी इक्वल टू, राइट, डायरेक्टली प्रोपोर्शनल टू द प्रोडक्ट ऑफ द मैग्नीट्यूड ऑफ द चार्जेस and inversely proportional to the square of the distance between them. Right, when we write this in the form of equations, what we can write? F is directly proportional to Q1 into Q2. Let this be equation 1, and we can also write F proportional 1 by R square, inversely proportional to the square of the distance. We can write this as equation 2. We can combine this equation 1 and 2 and we can get this F proportional Q1 Q2 by R square. What this actually means? This means that if this Q1 Q2 by R square increases, force is also going to increase, and this Q1 Q2 by R square decreases, then force is also going to decrease. मतलब इनमें से अगर Q1 Q2 by R square जो क्वांटिटी है वो इंक्रीज करता है तो फोर्स क्या हो जाएगा? फोर्स भी इंक्रीज करेगा, और ये Q1 Q2 by R square अगर डिक्रीज करता है तो फोर्स भी क्या हो जाएगा? डिक्रीज कर जाएगा। लेकिन ये नहीं बोलता है कि ये फोर्स और ये जो क्वांटिटी हम रिप्रेजेंट कर रहे हैं Q1 Q2 by R square दोनों इक्वल हैं। राइट, इक्वल करने के लिए इन लोगों को एक कांस्टेंट एक मल्टीप्लाई करना पड़ता है। वी नीड टू मल्टीप्लाई अ कांस्टेंट टू मेक देम इक्वल, एंड दैट कांस्टेंट ओवर हियर इज इक्वल टू, यू कैन सी इट ओवर हियर, F इज इक्वल टू K Q1 Q2 by R square. So K is the constant. And K's value is equal to how much? Right, K's value is equal to 1 by 4 pi epsilon naught. You can see it over here. K is equal to 1 by 4 pi epsilon naught. Right, so when I write F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, from this I can find the value of this epsilon naught. And what is this epsilon naught? Epsilon naught is nothing but permittivity of free space. If I want to write down this one, right, epsilon naught is nothing but permittivity of air or permittivity of free space. Right, and what is the equation we are having? F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, whereas this epsilon naught is nothing but permittivity of free space. So from here we can also find the value of epsilon naught. How? We can take this epsilon naught on this side and we can bring the F on this side. When we do so, what we are going to get? We are going to get this as epsilon naught equal to 1 by F 4 pi Q1 Q2 by R square. And once we get the equation for epsilon naught, we can also find its unit. And how will we do that? See, Q1's unit is what? Coulomb, right? And Q2's unit is also what? Coulomb. So it becomes Coulomb into Coulomb by what we are having? Force is there. So for force we can write down over here as Newton, and for R square we can write this as meter into meter, or meter square we can write down directly. So what we are going to get this as Coulomb into Coulomb becomes Coulomb square by Newton meter square. This becomes the unit for epsilon naught. This becomes the unit for epsilon naught. And You can see it over here. What is the value of epsilon naught? The value of epsilon naught is 8.85 into 10 to the power minus 12, and we can write down its unit also. And the unit over here you can see clearly. The unit is Coulomb square or Newton meter square, as we have found over here. So we also got the value of epsilon naught. When we have the value of epsilon naught, you see this whole portion. It is 1 by 4 pi epsilon naught. Pi is a constant, epsilon naught is a constant. So this whole thing 1 by 4 pi epsilon naught must be of some value, and you will see that its value is how much? Its value, you will be seeing this as 9 into 10 to the power 9. 1 by 4 pi epsilon naught is nothing but 9 into 10 to the power 9 Newton meter square per Coulomb square. So this is the value of 1 by 4 pi epsilon naught. See, the force, we are talking about the force between two charges. One is Q1, the other one is Q2, and we are talking about the force between two charges. When I say the force between two charges, right? So what it must have some magnitude, and it also must have some direction, because force always has magnitude and direction. Why? Because force is a vector quantity. Why it is a vector quantity? Because force requires both magnitude as well as direction. If force is having both of it, right, magnitude as well as direction, then force is a vector quantity, right? And what we can understand from that, right, we can understand that between Q1 and Q2 there is a force, and that force is equal to F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Now see, we will solve a question based on it, and this question has come in NEET 2020, it has come, right? And what the question is all about? See, study this, read this question, you will see the acceleration of an electron due to the mutual attraction between electron and a proton when they are 1.6 angstrom apart is how much? Basically, it has given you 4 options, out of which one you have to take. What has asked you? It has asked you acceleration of an electron, right? And it has given you some options over here, right? See, whenever you have such types of questions, right, first of all formulate what is given, and from there how will you reach to whatever it is asked, right? Acceleration is asked, but what is given? Proton, electron and proton is given. We already know that an electron and a proton, how much charge they are having. So basically we have to find the force, and when we have to find the force, we have to apply which law? We have to apply Coulomb's law. So by applying Coulomb's law, we will find the force between this electron and proton first, right? And once we find force, we can apply the formula F is equal to ma, and we can also find the acceleration from that, which is asked in the question. So for that, I have solved this one already over here. You can check it, right? So basically, what is given, right? Two charges are given. One charge is how much? 1.6 into 10 to the power minus of 19 coulomb. The charge on an electron, and the proton is also 1.6 into 10 to the power minus of 19 coulomb, right? We are just neglecting the minus on this side. So Q1 is equal to, we are having 1.6 into 10 to the power minus of 19 coulomb, and Q2 is equal to, we are having 1.6 into 10 to the power minus of 19 coulomb. So both the charges we are already having. And what is the distance between them? It is given in the question 1.6 into 10 to the power minus 10 meter. One thing you can already do it. If you are not able to recognize, what you will do is that while studying the question itself, you can mark on it, right? What is given? Electron is given. What is given? Proton is given. What is given? The distance is given. So you can mark it over here. And when you mark it, see, you can also write down 1.6 into 10 to the power minus of 19 is a charge. And over here also, which is a proton, means 1.6 into 10 to the power minus of 19 coulomb is the charge. And distance is already given as 1.6 angstrom. 1.6 angstrom means 1.6 into 10 to the power minus of 10 meter. So if you are writing like this, right, your half job is completed over here. Once you have done this one, you can go directly, you can calculate, you can put these values, you can calculate, you will get the answer. See how you will get it, right? So charges Q1 and Q2 is 1.6 into 10 to the power minus of 19 coulomb. So charge over here is 1.6 into 10 to the power minus of 19 coulomb because of the electron, and Q2 is a charge on the proton, and it is how much? 1.6 into 10 to the power minus of 19 coulomb. One thing we have done, we have neglected the negative sign over here because doesn't affect over here, right? So what is the distance? 1.6 into 10 to the power minus of 10 meter is the distance between them. And which formula will we apply? We'll apply the formula F is equal to Q1 Q2 by R square. How we have got this one? From Coulomb's law. Just before some time we have studied Coulomb's law. So F is equal to K Q1 Q2 by R square. What is the value of k? We have already found, we know 9 into 10 to the power 9. And what is the value of q1? We have already written down over here, and it is how much? 1.6 into 10 to the power minus 19. q2's value is how much? Again 1.6 into 10 to the power minus of 19. By r's value is how much? 1.6 into 10 to the power minus of 10 square. Right? So what we have done, we have just written down this much. Now just we have to multiply. See, one more trick I will tell you over here. See, don't have to multiply 1.6 into 1.6, right? Leave it as it is. Because why? In the denominator also there is 1.6. You can simply cancel them and you can get the answer, right? So 1.6 into 10 to the power minus of 10 square is there in the denominator. You can write that one as 1.6 into 10 to the power minus of 10 into 1.6 into 10 to the power minus of 10. Now you can cancel out 1.6. You can cancel out over here. And what in that case, what you're having? 9 into 10 to the power 9 into 10 to the power minus of 38 whole by 10 to the power minus 10 into 10 to the power minus 10. So basically, you're having 9 into 10 to the power 9 into 10 to the power minus of 38 by 10 to the power minus of 20. So you can take this 10 to the power minus 20 to the numerator. When you do so, what you will be doing? 9 into 10 to the power 9 into 10 to the power minus of 38 minus of minus 20. Why this becomes? Because from the denominator, if it goes to the numerator, this whole power will be subtracted from its power. Its power is how much? Minus 38 is there. So from the minus 38, this minus 20 will be subtracted. So minus of minus 20 becomes how much? Plus 20 it becomes. Plus 20 if it becomes minus 38 plus 20 is how much we are having? Minus 18. So what we will be writing? 10 to the power 9 into 10 to the power 9 into 10 to the power minus 18. That accounts to how much? 9 into 10 to the power minus 9 Newton. So we are having the force as 9 into 10 to the power minus of 9 Newton. But force is not our motive. Acceleration is what we need. So what do we know? F is equal to ma. If F is equal to ma, A will be equal to what? F by m. And F is equal to how much we are having? 9 into 10 to the power minus 9. Whole by mass is how much? Mass of the electron is 9 into 10 to the power minus of 31. So we can cancel out this 9 and 9. And this 10 to the power minus of 31 can be taken to the numerator. And when this is taken to the numerator, this minus 31 will become minus 9 minus of minus 31. Minus of minus 31 becomes plus 31. And so minus 9 plus 31 becomes how much? 22. So how much we are going to get? We are going to get the power as 10 to the power 22. Let us see such an option is there or not, right? See, out of the 4 options that we are having, one is 10 to the power 24, the other one is 10 to the power 23, 10 to the power 22 and 10 to the power 25. So which is the correct option? The correct option is 10 to the power 22. So like this you can solve. Thanks a lot.